Welcome to Math 1332, Chapter 3, Section 6, in order to get the homework problems. First, let's review what our negation rules are. If you negate a conditional, an if-then statement, so if not if-then becomes P and not Q. And then we have De Morgan's laws, which were if you negate an and statement, it becomes the negation of P or the negation of Q. The negation of an or statement becomes negation of P and negation of R. Of Q, I mean. So, once we have those rules down, now we can do the rest of these questions. If I am in Acapulco, then I am in Mexico. Write the negation. So, this is P. If P, then Q. So we have to leave the first one alone. I am in Acapulco, and I am not in Mexico. So remember, it's no longer an if statement, it's an and statement. So I am in Acapulco, and I'm not in Mexico. First one, C. Write the negation of the conditional statement. If, here's the if P then Q, the negation of it, so this is P, this is Q, so let's take the negation of it. What is the negation of it? Is P, which is, it is pink, and the opposite of a not is yourself, so it is calm. Alright, clam. I'm sorry. It is a clam. So it can't negate the first ones, so it's got to be the other two. And we have to take the negation. And since this is already a negation, so it's C again. Remember, it is not a clam. It is not a clam, becomes it is a clam. Number 3. Write the negation. If I am in Sacramento, then I'm in California. The negation, this is P, then Q. The negation is P and not Q. So, I am in Sacramento. So anything that has a not, let's see, we could use those. No, it's backwards. So P, if I am in Sacramento, we have to have the and. That's an or. That's an or. That's a, oh, let's think about that one. But let's consider that one. That's an or, we can't use that. And. So, we want to go to P is I am in Sacramento and I am not in California. The only one that states that is H. Now number 4, write the negation of the conditional statement. If there's an ice storm, then all restaurants are closed. If P, then Q. P, then Q. The negation of it, P and not Q. there's an ice storm, then all restaurants are closed. That one. It's not an if-then statement. Okay, there's an ice storm. There's an ice storm. Not or. It's got to be and. All restaurants are closed, so the negation of all is some are not closed. 4 is D. All right. Use De Morgan's law. Rewrite the statement. It is not true that Tom and Jerry are both friends. Remember, De Morgan's laws negates the and or. So P and Q becomes not P or not Q. Not P or Q becomes not P and not Q. It is not true that they're both friends. So now that is an and statement. It is not true that Tom and Jerry are friends. So since we have this is an and statement, we have to go to Tom and Jerry, Tom or Jerry. So if Tom, it's not an if-then statement anymore, it's an or statement. Tom is a friend or Jerry is a friend. This is not true. So that means either Tom's not a friend or Jerry's not a friend. Tom's not a friend or Jerry's not a friend. Tom's Jerry. And, nope, it's got to be the or statement. So D. Use De Morgan's law and to write the statement that is equivalent to the following statement. Okay. Remember, De Morgan's distribute. So we have not Q, not or, not P. Not Q becomes Q. Not or becomes and not P becomes P. So it's Q and P, which is D. Use De Morgan's laws to write the statement as equivalent to the following statement. If you attend the game and cheer, you support your team. If you support the team and cheer, so it's an if statement. So support the attend game and cheer then you support team. Okay, so use De Morgan's laws to rewrite this. So if we negate the statement as equivalent to, okay. So what this is saying that if you support your team, okay, so that's an if statement, that's the if part. So what De Morgan's is negation of the simple statement. Remember, when we negate an if-then statement, we have to use this formula. So we have P, then Q. If we negate the conditional statement, there's P and not Q. So this is P, this is Q. If we negate this statement, Then we get P, which is attend, and cheer, this becomes and not support. So this is the P part of the entire the conditional statement, P, Q. That's the part. We would leave the entire P part alone. So if you attend the game, if you attend and cheer, then you do not support your team. So if you do not support your team, the negation of this statement isn't using De Morgan's, just becomes not attend or not cheer. So if you do not support your team, then you did not attend or cheer. If you do not support your team, then there's an or statement. Then you did not attend the game. No, it's not and, it's an or statement. If you do not, it's got to be if then. So if you don't support your team, then you did not attend the game or cheer. Now, if you didn't support your team, then the negation of this becomes you didn't attend or cheer. That's De Morgan's laws. Use De Morgan's laws to write the equivalent statement. Remember, De Morgan's laws. De Morgan's deals with the and or. So negation of and or. So we have a conditional statement here. If not R, then not this, or then this, not P or not Q. The negation of it. The negation of not R is R. The negation of this or statement, so we have to negate not P, so it becomes P. So we have R, P, and Q. So use De Morgan's to write the statement that is equivalent to the following statement. So that's what that one is. So if this is a true statement, then we know that its converse is also true. So we negate all the terms, so it becomes A. P and Q are. Yeah, because whenever you negate using De Morgan's, that has to become an and, so it can't be that one. Well, we negated R, it can't be negative R, it can't be negative R, so it has to be positive. Use De Morgan's law to rewrite the negation of the following. So this is our statement. Not Q or P. If we negate that entire statement, then we distribute. So not Q, not or, not P. So those cancel, so we have Q. Not or becomes and, not P. So it's Q and not P. use De Morgan's laws to write negation of this statement. So this is the entire statement. If I was to negate it, distribute, so I have not P, not and then not Q or not R. So not P becomes P, not and becomes or. Now here we have De Morgan's again. So we have to distribute there. We could so that becomes not Q, not or, not R. So it becomes not Q and R. Not Q and R. But, I mean, this has to be done first, so that's why I need the parentheses there. Use De Morgan's laws to rewrite the negation of the statement below. Express the negation in a form such that the symbol tilde negates only simple statements. Okay, so it's an if-then statement. The rule we're going to use is not P. If P then Q becomes P and not Q. This is P, this is Q. So our first statement becomes not, so this is P, that's Q, so leave P alone, R. This then statement becomes the and. Now we have to take negation of not P and Q. We use De Morgan's for that, so we are and not P is P, not and is or, not Q. Alright, so we get R and this next part is P or not Q. R and P or not Q. That was pretty confusing. Just the way they want you to write the answer down. Write the contrapositive. Remember contrapositive? The contrapositive is when we flip and negate. So it's a flip and negate. So write the contrapositive statement. So cream is necessary for Alfredo sauce. Then if you have cream, then you have Alfredo sauce. Alright, so we have to put it in as a conditional statement. If cream, then sauce. So if there's no cream, then there's no Alfredo sauce. So if this one can't be right, this one can't be right because it's got to be negation. If there's Alfredo sauce, then there's cream. No, it has to be both. If there's no cream, then there's no Alfredo sauce. So the negation of that, yeah. So write the negation of the statement. Choose the correct below. The negation. Cream is necessary for Alfredo sauce. Cream is necessary for Alfredo sauce. So if cream, then Alfredo. So now if I negate these, I get conditional statements. So I have P and not Q. So I have cream and not Alfredo. So I have cream and no Alfredo. There is Alfredo sauce and there is cream. No, we cannot have no Alfredo, so it can't be right. There is cream and there is no Alfredo sauce. This one could be it. There is no cream or there is no. It's got to be an and statement, so it can't be that one. It's not conditional anymore, it's an and statement. There is Alfredo sauce and no cream. There's Alfredo sauce and no cream. If there is no Alfredo sauce, then it's not an if-then statement. So the only one that are and are those two. Write the negation of the statement, yeah. The statement is cream is necessary for Alfredo sauce. So it's going to be either B or E. There's cream and there's no Alfredo sauce. There's Alfredo sauce and no cream. Depending on how you read that statement, if you have cream, then do you always have cream? Let's see. Is it true if cream then Alfredo, or if you have Alfredo then you have cream? Which one's always true? Will Alfredo be the only thing if you have cream then you have Alfredo, or if you have Alfredo then you have to have? This has to be the true statement. This has to be the true statement. So this is P and Q, P and not Q. So if you have Alfredo and no cream. Let's go back to this top one then. The contrapositive. Because if it's P is Alfredo, Q is cream, so if Alfredo, then cream becomes no cream. No, the negation is Alfredo So let's flip these two around. So it's no cream, then no Alfredo. Yeah. So this is P and Q. We flip them and negate them. If there's no cream, yeah. Okay, yeah. So those are the answers. I'm sorry about that. I have to think about that. Right. Good luck, and remember, when you ever get stuck, just tear down and read the statements. Statements have to be true or false. They have to be logical statements. All right, good luck.